everyone, this is Christian, and today I'm going to show you the new Swiss Army knife for logs and metrics monitoring, Grafana Alloy. If you've been following my HomeLab videos, you know that I already made many tutorials about Grafana, Prometheus and Loki, but in these tutorials we've always used different tools and configs to transfer logs and metrics between all these systems, depending on what you want to monitor: Linux, Docker, Kubernetes, databases or services. It could get quite complex and very fractured. But now with Grafana Alloy, we are simplifying and centralizing the entire telemetry collection and processing for all of these systems. Originally, I just wanted to use Grafana Alloy to replace Promtail, as this got deprecated a few months ago by Grafana, but then I found out that Alloy doesn't just replace Promtail. It can replace many others of these tools, like the Loki Stalker plugin or Catvisor. With Alloy, you don't need them anymore, and it can even do so many other cool things like filtering and changing telemetry before it's sent to Loki or Prometheus. It's really an amazing tool with many features, but I'll be honest with you guys, the configuration of Alloy wasn't exactly intuitive at first, and there's quite a learning curve in Alloy, so that's why I thought it is time for a good deep dive tutorial about this amazing tool. So in this video, I'll show you exactly what Alloy is, what makes it so special, and how I'm actually using it in my setup to centralize all the logs and metrics collection. Before we dive in, let me quickly show you another amazing tool that I use in my HomeLab for centralizing my IT automation, called Kestra. Because Kestra is a powerful and simplified workflow orchestrator that helps you automating all your tools and APIs in one central platform. For example, I'm using it to schedule several HomeLab automation flows like my Python scripts or Ansible and Terraform tasks, and I'm also planning to use it for my new website CI/CD process. But of course, you can build whatever you want with Kestra. Its declarative language allows you to create powerful workflows by using triggers, loops and logical operations, and it supports over 600 plugins, allowing you to build automated workflows with unlimited possibilities. Kestra also has a great web UI with a real-time monitoring dashboard where you can drill into all the execution metrics, debug logs, time-based diagrams and so many more things. And the best is Kestra has an open source version that you can just easily deploy using Docker, Kubernetes or other tools in your HomeLab completely for free. I've already made some video tutorials about Kestra, and I'm certainly planning to do more, so definitely check them out for a full deep dive. And if you're ready to use Kestra in your company environment, then reach out to the team about the enterprise version. They really have a good support. Of course, I'll put you the links to Kestra and my video tutorials about it in the description of this video. Alright guys, so now let's get started with Alloy. This is the new tool that was introduced by Grafana, and it combines the strengths of leading telemetry collectors, which in our case basically means logs and metrics. And if you take a look at the official documentation about Alloy, you can see this overview diagram. On the left side, you have your applications and infrastructure such as Linux, containers, scripts and so on. And on the right side, you have your databases and collectors like Prometheus, Loki, and some others. By the way, if you haven't watched the previous tutorials about Prometheus, Grafana, and Loki, you probably should check them out. Otherwise, it might be hard to follow this one, so I'll put them all in a list in the description box of this video. Certainly also check out my boilerplates repository on GitHub, so there you will find all the templates and the configuration examples, and you don't have to write down everything while watching this video. One thing that is really important to understand, the heart and core of Alloy's configuration are the so-called components. Components are the building blocks of Alloy. And Alloy supports over 120 different components to collect telemetry data from several applications, databases, and open telemetry collectors. And it even supports custom components for maximum extensibility. Each component in Alloy has a name that describes its responsibilities. For example, here we have the local.filematch that basically discovers files on the local file system. And every component also has a user-defined label so that you can easily reuse your defined components in other pipelines and chain them together. To deploy Grafana Alloy in your environment, you have a bunch of different options. Like you could use a simple Docker container, you could deploy this on Kubernetes or on Linux, macOS, Windows, and also use other platforms and automation tools. Now, with this simple command, you can easily start up a Linux Docker container. However, I'd like to start with my Docker Compose template for deploying Grafana Alloy in my HomeLab because I needed to make a few adjustments to this simple command. So again, you will find this template as all the other templates and also the config examples on this GitHub repository. So definitely check that out. And to get started, I will just copy this and go to one of my testing servers, and let's create a new project directory for Alloy and open this in VS Code. So here I want to create a new compose.yaml file where we can paste in this template. And let me quickly go through some of the options so you know why I've created them and what is necessary for you to adjust depending on your environment. So first of all, I just want to deploy one Alloy container with this version. And then I also want to set the hostname variable. So this is a function in Docker Compose that will pass through a specific hostname to the Docker container. Otherwise, Grafana Alloy, because it's running in a simple Docker container, it will just use the randomly generated container ID instead of the real hostname. Unfortunately, it doesn't work to use environment variables here for whatever reason. So in my case, I needed to specify the hostname manually. Then we need to start the Alloy application with these command parameters. So here we make sure that it's listening for incoming network connections, because Alloy also has a small web interface where you later can see some debugging and information about the telemetry that it's collecting. So this might be pretty useful sometimes. And of course, we also set a storage path. So this is necessary because when Alloy cannot connect to Prometheus or Loki for whatever reason, it can buffer the telemetry and retry the connection to send it again when the database services are online. So therefore, it's useful to have a storage. And also, we want to start this with a specific configuration file. We just need to create it in the same directory that is called config.alloy. And here we will later put in all of our configurations. So then we also have a persistent volume for the data storage. And I'm also passing through a bunch of mount points from the host operating system to this Grafana Alloy container. This is again necessary to collect logs and metrics from the host operating system and send them to Prometheus or Loki. I also connect this to my traffic instance so we can easily protect this web interface with HTTPS, and maybe you might also want to add some basic authentication or an authentic middleware, whatever you want to do with it. We will not focus on this stuff for that video, but I just leave it in. It's not going to hurt. All right, so this is a setup. Now let's start having a look at the configuration of Grafana Alloy, because by default it's not doing anything. You need to specifically define these components that I've talked about earlier to decide what it should collect, how it should process it, and where does it send it to. Now, I first of all want to start with a very, very simple use case. And this is by just simply replacing Promtail. Because if you remember from my Loki tutorial, Promtail is there to collect logs from the local operating system and send it to Grafana Loki. So if we go back to my testing server for this video, I've already created a Promtail container with a simple configuration example here. Again, this is not a very sophisticated configuration, but I'm happy that I didn't went too complex with Promtail back in these days because it was deprecated anyway. But just imagine you have Promtail in your environment deployed and you simply want to migrate this to Grafana Alloy. This is super simple because here in this documentation, you can see you can easily convert an existing Promtail configuration to a Grafana Alloy configuration. So again, this is the configuration for Promtail. And then let's run the convert command. The source format is Promtail. The output will be alloy.config and config.yaml is our existing file. All right, let's run this. And then you can see this is the configuration file that the Alloy conversion tool has created. So let's just copy this and put it into this configuration file so we can start using this. And this migrated config, again, I said, isn't actually a good one, but it serves as a very basic example to explain some of the important elements of an Alloy configuration. So you get a better understanding of how this is structured and what you need to change in order to make customizations to it. So we will first of all start with the Loki.write component. So this is basically a component with our custom label default to write all the received telemetry or the received logs to a specific endpoint. I've already created a new monitoring stack on this testing server. So here you can see this is currently running a Grafana, Prometheus, and Loki stack just for testing purposes. So let's return to the Alloy configuration and replace the URL with the protocol HTTP because it's currently inside the Docker network, not encrypted. The container name is Loki and the port is 3100. And we can address this specific component with our custom default name in the Loki source file system. So here you can see this is a connecting component that connects the local file match system. So here that is the target, and it's forwarding to the Loki.write default receiver. The main reason why it's using this complicated way with the components is that you don't have to define that component every time. You can just refer to this address and all the parameters and the configs are existing in that one object. It will later probably make a lot more sense when you see the graph in the Alloy web interface. Let me just continue configuring this because one thing that I want to change here, currently it's sending all the logs with the log ending to that specific job. So for example, if you want to add another path target, it would look something like this here. And then you can just copy this and, for example, match different files. You could also customize labels later and so on. And here, for example, we just want to use the auth.log. So now this is a very basic configuration, but assume you want to make any changes or modifications to the telemetry or to the log files that are collected from these files on a local disk. We can use other components. For example, if we go to the Alloy's documentation, you can see in the reference a complete list of all the different components. So for example, if we go to Loki relabel component, you can see this is a component that rewrites the label set of each log entry. This way you can modify with rules, regular expressions, replacements. You can change certain things that are collected to really customize what exactly do you want to process and what you want to send to the receiving system. So that is really, really powerful. For example, if I want to collect the host operating system and add them to the telemetry that I'm sending to Loki, so we will just use this here. Loki relabel, then we give it a custom name. For example, let's just call this system. And everything that this component is receiving will be sent to the Loki.write component. So we basically just copy the target address from the source file system, put it in here. And what we now need to do is we need to address our relabel component here so that it first goes to the source file, then it goes to the relabel, and then it goes to the write component. So the way how you do this is also pretty simple. You just address it by the component name, relabel, and then the custom name, that what you put in here, receiver. Here you can see this is the input receiver where log lines are sent to that should be relabeled. Okay, so that's the way how you do this. Of course, you need to define a relabeling rule here. For example, if we want to create a new label called operating system, and that we want to replace with OS. You will also find here in the reference, when you go to standard library, constants, and here, for example, there are some variables that you could use. For example, hostname, this will always contain the hostname of the machine where Alloy is running on. .os is the operating system where Alloy is running on. Architecture, version should be also self-explainable, right? And if we just run this on the system, I think we should give it a try now, because we've configured a few different things. I'm just realizing this will be a super long video, but anyways, I hope you still enjoy it. And let's see how this is working. Okay, I made a mistake somewhere in the configuration file, so definitely don't start this in the background at first, because you see any errors in here. Missing comma in the expression list. I forgot to add a comma here. For whatever reason, it needs a comma at this point. All right, so no, Grafana Alloy is up and running and it's doing its thing. To check if this is really working, we can open a new connection to the test server with a port 12345. Again, this is the small web interface of Grafana Alloy. So here you can see this is a very simple web interface. I'm sorry for the light mode, but it doesn't have a native dark mode. Here you can see the health of all the components that we have defined. You can also view all the details about it and what's the current configuration. And what is pretty cool, when you go to Graph, this will visualize the chain of the components. So where the information is coming from and where it's finally sent to. You can see that it's going through the relabel system and then it's written to the Loki's database. Let's also open my Grafana interface on this testing server. So when we go to drill down logs, you should see the server test 1 system job that we have configured. If we go to show logs, you can see these are the log entries that Alloy is collecting from the log files of the host operating system. And if we go to labels, you should also see that our operating system label is now generated by the relabel component of Alloy. It's reporting the Linux as the operating system. But also here in the file name, you can see the 2 file names, var log auth and var log dmessage. So you could also filter it based on that file name. And this is how you can simply send logs to Loki with Grafana Alloy. If you just were interested in that, you can stop the video right now and call it a day. Yeah. However, I would still recommend you to keep watching, because we're now coming to the most interesting part, in my opinion. Because as I've told you in the beginning, Alloy isn't just great to replace Promtail and send simple log files. It can replace a variety of different things. For example, in addition to the log collection from the host system files, it can also collect metrics and aggregate them in a Prometheus database. This is a very similar type of database like Loki, but just for metrics instead of logs. And Grafana has, by the way, created a super practical and helpful GitHub repository that can serve as a template for so many different use cases. So this is also the way how I personally got a much better understanding of Grafana Alloy. For example, if you go to monitor metrics and logs, here you have some great examples. Go to monitor Linux, and here you will find a link to a GitHub repository, Alloy scenarios. So if we take a look at this, here you will find configuration examples for several use cases, such as Linux operating systems, Docker monitoring, logs for TCP, files, mail systems, syslog, Windows. So this is really nice. And let us first start by taking a look at the Linux example configuration file. So here again, the Docker compose and Loki config you don't need to take care about, but the config.alloy, this is the part that really interests us. So as you can see, this is quite a complicated example, but let us go through this and I will show you how this basically works. So this is combining 2 things here. It's combining logs plus metrics. So it's doing both in the same config. But first of all, let us go through collecting metrics. What we need for collecting metrics is, again, a Prometheus database. So let us just stop the container and let's modify this a bit. I will need to make some comments in here, because otherwise I'm getting confused with the long config. And let's call this Promtail example. Yeah, I think that's fine. And what I also want to do is I want to add a section for targets. So I want to take the Loki write component, take it out from that and put it here under the targets. And in addition to the Loki write default, we also should have a Prometheus of write component. So you can also find it here. Prometheus remote write. So that is another target. I will rename this from local to default to just have the same name consistency. I don't need this comment. And I think the URL should be correct, because my Prometheus container should also have the name Prometheus. Oh yeah, it's in here. One thing that is really important if you want to send metrics to Prometheus. By default, this is not working because usually, if you know from my Prometheus tutorials, Prometheus in general would usually scrape the metrics, so it would pull the metrics from sources. Now with Grafana Alloy, we are using it the other way around. We are not pulling metrics with Prometheus, we are sending metrics, so pushing them from Alloy to Prometheus. And by default, Prometheus does not allow this. Therefore, I needed to change my Prometheus monitoring stack configuration and add in a new flag to the command. That is this here, web.enable remote write receiver. All right, so that's what you need. Restart the Prometheus container, and then you can configure it as a target in Alloy. And the next thing that I want to do is, of course, we just defined the target component. Now we need to build the component chain for collecting the metrics. So here is the Loki stuff. I think all the other important stuff for metrics is above here. I will just copy all of that stuff and then let's go through this together. In Prometheus, you would usually do it this way. You would have Node Exporter. This is a simple application that opens a web interface and exports its metrics in the Prometheus standard format so that Prometheus could connect to the machine where Node Exporter was running and scrape the metrics. With Grafana Alloy, you don't need any of this. You don't need to install Node Exporter on the system. You don't need a scrape job in Prometheus. You just need the Prometheus.exporter Unix components. So this is scraping all the necessary metrics from the host operating system. And then we have another component, the discovery relabel component. So this is basically setting the instance, the host name, to the instance target label and the integrations node exporter to the job label. And the connecting component is this Prometheus scrape component. So this will receive the metrics from the relabel component output and forward them to the Prometheus remote write receiver. Again, we just renamed the remote write to default from local, so I need to change it here. Otherwise, it has a different name, so it's not finding that. And for the simplicity, I'm also making this a bit smaller and better readable. And I'm gonna change a couple of these names. So for example, this integrations node exporter. This is, in my opinion, a bit complicated. I'm just changing this to metrics to make this a bit simpler to read. Yeah. Okay, so now what I also want to do is I want to replace the job name because I don't like this to be integrations node exporter. If you want to filter this for different servers, I think it would be nice to have a separate job for each server where Alloy is scraping the metrics on. So similar to how we are doing it here above with the instance name that is replaced to host name, I want to use a simple string format to add the dash metrics at the end of the host name. You will later see in Grafana how this is looking like, but I found this to be the best way for me to manage the job names for several different servers here. All the other stuff we usually don't need to touch because I think it's a really good example. If you want to make any customizations to it, feel free to do it. But in my opinion, these scenario examples are already pretty good. And if we have it in this compact format, I think it's easier to understand. Let us first test if that's working because we changed a lot of things here. If I might run into a different error. No, it seems okay. So hopefully everything is working fine. Let's again open the Alloy component in here. Oh yeah, so you can see this now has been updated. Here you can see first the Prometheus exporter is scraping the metrics from the local system. It's sending this to the relabel metrics components to add the host name and instance labels. Then it's scraping this and sending it to the Prometheus write. By the way, the numbers here, you can also see the latency between these jobs. Also pretty nice to troubleshoot and monitor this. For example, if you whoops, what the hell is that here? I think that's because I'm using a private browser. Let's go into the Grafana drill down metrics. So here you should see, let's go to last 15 minutes. So here you can see it's start to show up some metrics from the system. Of course, this is in the drill down. It's a bit hard to read. So therefore, I've added a dashboard called Node Exporter Full. So here, this is the same Node Exporter dashboard that I would use for the old Prometheus scrape job. So if we go to last 15 minutes, so we can see, yeah, the graphs are filling up, so everything should be fine. Yes, you see, here you can see the CPU, memory utilization, network traffic basics, and so on. And here in the job, you can see it's saying server test 1 metrics, because in the configuration, we have added the dash metrics to the host name as a job label. So feel free to change anything in here. The node or the instance name is server test 1. Remember, when we go back to this here, we set it to that, and you need to change this to the real host name where you deploy Grafana Alloy, so then you can easily scrape logs and metrics for all your different servers, and you can easily filter them out in the dashboards later. So that's really nice. But yeah, as you can see, this is working as expected. No need to change anything in here. The next thing that I want to show you is when we go back to the scenarios here, you can see there are also configuration entries for Loki. So this is collecting logs from the local file system, but not only from the local file system, also for the journal, the system's D journal for node exporter. This is what was not possible with Promtail so easily, right? So it is also nice. So we might want to replace the existing Promtail configuration or the Promtail replacement configuration with this one here. Let's go back in here. Let's first of all stop the container. I think if we change the configuration, you need to restart the container to make this active, but yeah, okay. So we will delete this Promtail example. I think we don't need this anymore. Let's instead call this system logs and this here system metrics. Let's put it in. And of course, I'm going to clean up some of the comments here. And of course, what I need to do, we don't need to define the Loki write component again, because we defined that above in the targets just with a different name default. So whenever I'm seeing this address here, we have to use the name default to match our target component to send it to the Loki database. All right, but now we have two separate sections here. We first have the journal. So that is this source here. This will scrape the systemd journal, send it to the relabel rules. So that is this component here. I suppose it is necessary to match specific source labels that come from the systemd journal component to match them into the Loki format correctly. So it's very simple. This is just a 1, 2, 3 component chain. And then we have the system local file match. Again, this is what was used by Promtail as well, but it's scraping the syslog messages and any other file that ends with .log, adds the instance name, host name, and again, this is this integrations node exporter. Again, I want to replace this with the string format like we did below in the metrics. But of course, this time I don't want to add metrics. Here I want to add logs. All right, but I think that should be all, nothing else. Don't worry, I will later on put these examples in separate files on my own boilerplates repository so that it is a bit easier for you to read and copy and paste these. But let's again try if that works as well. So yeah, it looks great. And let's return to my Grafana instance. Now we need to drill down into logs. And here you can see, by the way, this is the system is the old job from the Promtail replacement. We don't need this anymore. No, well, the journal is still missing in here. And I think, yeah, I know where this is coming from. There is an open issue on GitHub. When Grafana Alloy is running in a container, you need to add something to the journal scrape job. So this should be here, source journal. Because when it's running in a container, we need to add this here, the path, and set this to var log journal. Don't ask me why this is needed. I just found it somewhere in an issue on GitHub. There somebody said you need to set the path when Alloy is running in a container if you want to scrape the systemd journal. I don't know the reason why, but I just added this and then it's working fine. And I also added a label to change the job name -journal. So then we should see this as a separate job in the Grafana instance as well. So make sure to add these two if Grafana Alloy is running in a container. Otherwise, the systemd journal doesn't really work. Let's restart it. And then if we refresh, now we should see a third item. Yeah, so here you can see server 1 journal. So these are the system D journal logs, and above here the server test 1 logs. Let's refresh it to last 5 minutes. So these are the 2 jobs that we have created. All right, so now this is everything about metrics and logs. This is the basic configuration, how you can send logs plus metrics with Grafana Alloy to Loki and Prometheus. And you don't need anything else. You don't need Promtail. You don't need node exporter. You just need your monitoring stack and deploy Alloy with this configuration on all your hosts that you want to scrape logs and metrics from. I think this is really comfortable and practical, but I'm still not done. I know it's a long video, and yeah, feel free to jump off if that's enough for you. But I still would say there's one more thing that is really important, and that is scraping logs and metrics for Docker containers, because this is such a big topic that I had covered in previous tutorials on this channel. Remember, we needed to deploy the Grafana Loki's Docker plugin. We needed to add the logging driver labels to all our containers that were running on this system. And honestly, maintaining this was really a huge pain. And with Grafana Alloy, you can do this all without needing the Docker plugin, without needing to add anything to your Docker Compose labels. This just works with a single configuration and a single application. This is so incredible. So therefore, I thought this is so valuable. I need to show this to you. So let's go back to the Alloy scenarios. Here we have another example, Docker monitoring. So when we go into this Alloy configuration, what the heck is now going on? I don't know what's refreshing it. Okay. Anyway, so here we are. It's now working. So here you have a better structured configuration. You see here above is the metrics configuration for Prometheus. There is the logging configuration. And I thought, let's just copy and paste this and test it. So let's copy it here. First of all, I want to stop the Alloy container. Let's go back to the config file and let's put it at the end here. I think that's fine. We just need to replace the targets, of course. Yeah, you probably should know this from the other jobs. So here, the Prometheus remote write demo that we need to delete, and we will replace demo with default to send it to the same Prometheus instance. And I will probably simplify this Docker metrics. Okay, so then we have system metrics, we have Docker metrics. These are just these 2 components that are necessary. I want to change the example and the scraper also Docker metrics. Okay, that's fine. All right, and then we have the logging configuration, Docker logs. We don't need to define the Loki write. So Loki write local we set to default. And I think that should be all. Let's try and test it out, I would say. So let's deploy this again. Let's refresh it. And okay, so here you can see the logs are popping up for the Alloy container. Now we see the logs for Grafana and for traffic as well. So basically all the Docker containers that are running on my system are automatically scraped and the logs are sent. Of course, we should also still check the metrics here. Here you can see 8 running containers are on my system. Depending on what dashboards you have, the CPU usage of the containers, you can see the metrics and the logs for all your containers running on the system as well. With just these simple configuration settings, I think whenever I need to collect telemetry, so logs and metrics for containers or operating systems, or maybe I will extend this to test out how to scrape metrics from Kubernetes pods or maybe databases, I will use Grafana Alloy as my one and only component that basically does it all. So I'm super excited. Okay, whoa, so we are finished with this tutorial. I know it was a lot, and honestly, I'm really exhausted right now, but I hope it was valuable and I could take a little bit away the fear from you when it comes to configuring and using Grafana Alloy. And maybe you got some great ideas and inspiration to replace some of the older deprecated telemetry collectors in your HomeLab with this new application. Please let me know if this was helpful and valuable to you, and if you're interested in seeing other scenarios with IT monitoring and Grafana Alloy. We haven't collected telemetry from databases or Kubernetes clusters, so there's a lot we could cover in the future. Please let me know in the comments if you're interested in. And as always, thank you so much for watching this video. Congratulations that you've made it to the end. And a big thanks goes out to all of the Patreon supporters and YouTube members of my channel. You guys are really amazing. And I'm gonna catch you in the next video. Take care. Bye bye.